Our previous chapter that we were going over was verifying when triangles were congruent, okay? This chapter, what we're going to be looking at are similar polygons or similarity in general. What does that mean? Okay, our first chapter, or little piece that we're going to be talking about is the similar polygons. How do I know if one shape is similar to another shape? There are two things that our similar polygons have to check off a list. Okay, one of the two things is all corresponding angles have to be congruent. So all corresponding angles are congruent. What that means is if we have a triangle, all three angles from the first triangle have to be equal to all three angles of the second triangle. Or we have trapezoids up here. All four angles have to be congruent. As long as the angles are congruent, that is one check on our list. Then we have to move to the second check. The second check is all corresponding sides are proportionate. And we'll talk about what that means here in a second. So, all corresponding sides are proportionate. Not congruent, but proportionate. What that means is that they're going to follow the same ratio from side to side. Let's dive in and take a look, and it might be easier to understand. So I have an example here where I have two triangles. First thing I need to check is, are my angles congruent? So all three angles have to be congruent. So I have a 36 here, 36 here, 89, 89, 55, 55, check. So my angles congruent, check. So now I need to know, are the sides proportionate? That's my lingering question here. So what I'm going to do is I need to compare these sides, and I have to make sure that I'm comparing corresponding sides, so in the same position. So if we notice, 36 to 55, that side length is 12 and 6. So I'm going to set them up like a fraction, 12 over 6. Then I have 55 to 89, that is 6 and 3. So this fraction has to be equal to this fraction for them to be proportionate. And then my last sides are 8 to 4. There are a couple different ways that we can check this out. If our fractions are reducible, we could go ahead and reduce them down, or we could do some cross multiplying to check here. This one's really simple because all of them will reduce to 2 to 1. Since all three of those reduce to the same value, our sides are definitely proportionate. Another way I could check this is I could do some cross multiplying. 12 times 3, that's 36. 6 times 6 is 36. So those two fractions are proportionate. Okay, then here. 6 times 4, that's 24. 3 times 8, that is also 24. So these two sides are proportionate. That's perfect. But then I have to check the third side. 8 times 6 is 48, and 12 times 4 is also 48. So again, I'm seeing that those sides are proportionate. My two triangles are similar. Just like with congruency, we had a congruency statement. That congruency statement told us what sides were congruent to what sides, what angles were congruent to what angles. We can do the same thing with similarity, but instead of telling me that the sides are congruent, I'm telling you which sides are corresponding, which sides are proportionate. So if I were to label this and say A, B, C, and J, K, L, I now know triangle ABC is similar. So this little sideways S means similar to, so if I start at A, that means I'm starting at L. A to B is L to K. So to triangle LKJ. Okay, triangle or angle A is congruent to angle L, B is congruent to K, and C is congruent to J. And the corresponding sides are proportionate. Okay, long video for one example. We got 2 more examples just checking to see if they are proportionate. So the first thing I want to check are my angles congruent. So those 2 are equal to those 2, and these 2 are equal to those 2. Check. So then we're going to compare the corresponding sides. So I have 12 to 4, and then I have 21 to 7. And then I have 13.8 to 4.6. I don't need to worry about testing that 4th side because it's still just going to be the 13.8 over 4.6. Okay, so what I'm going to do is I can't reduce, well, I could reduce, actually. So 12 over 4, that's going to reduce to 3 over 1. 21 over 7 is 3 over 1. And then this guy, I'm not quite certain, so we're going to do a quick check. So this is saying 4.6 should be equal to 13.8, so let's give it a check. 4.6 times 3, that's 18, 12, 13.8. Yep. So all 3 of those reduced to 3 over 1. So I'm going to say, yes, these are proportionate, and the scale factor is 3 to 1. So that means this trapezoid is 3 times the size of this trapezoid. Again, this is called the scale factor. Over here, our scale factor was 2 to 1. You could also keep it as a fraction. 2 over 1 means the same thing. Okay, here I have a rectangle compared to a rectangle. They have the 90 degrees, so the angles are congruent. So let's go ahead and check the sides. So I have 42 to 7, and then I have 18 to 5. When you're setting up the proportions, as long as you're setting them up in the same order for each fraction, it doesn't matter how I set it up. I could have also set this one up and said 42 to 18. So long side to short side is equal to 7 over 5. Long side to short side. Notice I'm still cross-multiplying the same numbers together. That's why it works. That's why it's okay. All right, my 42 over 7, that's going to go ahead and reduce, give me some nicer numbers to 6 to 1. But my 18 to 5 will not reduce, so it is 18/5, and these are clearly not the same fraction. And again, we could check it and do our cross multiply. That's asking, is 18 equal to 30? Nope. So these are not similar. Yeah? Okay. See what you can do with that? See you in the next video.